concentration of solutions. So that expresses the amount of solute dissolved in a solution relative to the amount of solvent or the solution altogether. So a dilute solution, of course, there's going to be relatively little dissolved solute compared to the amount of solvent. Concentrated solution, of course, the other way now. Now we've got a relatively large amount of solute compared to the amount of solvent, right? So the first type of concentration we're going to look at is mass percent. This refers to the mass percent of the solute in the mass of the solution. So it expresses the concentration of solution as a mass of solute in a given mass of solution. Here's the actual calculation. So it's just a percentage, right? We've all done percentages when we look at how much are we getting off, when they discount an appliance or whatever it happens to be, or pay has gone up 7%. Well, then what's my pay going to be now? That sort of thing. So here it is, and any percentage is just a fraction. So here we have a fraction. It's the mass of the solute over the mass of the whole solution, right? So that means the mass of the whole solution, you got to add the solute and the mass of the solvent together, right? So anyway, you have a fraction. All percentage is just a fraction multiplied by 100. That's all it is. So just get the fraction for solute over solution multiplied by 100. You've got your mass percent. Let's take a look at some examples. Okay, first one here. What is the mass percent of sodium hydroxide in a solution that is made up by dissolving 8 grams of sodium hydroxide, NaOH, in 50 grams of water? Okay, which would be 50 milliliters of water, taking the density of water to be 1 gram per milliliter. Let's take a look at the answer for number 1. Okay, so as we know, mass percent of the solute is just mass of the solute over mass of the solution, which equals 8 over the 50 plus 8, which gives us 58 altogether. So our fraction is 8 over 58. We multiply it by 100, and it gives us 13.79%. Let's look at the second one. What masses of potassium chloride and water are needed to form 250 grams of a 5% solution? Now that 5% refers to the mass of the potassium chloride, right? It's the solute. Water, for what we're doing, will always, always, always be the solvent. So what this means is the mass of potassium chloride is 5% of the mass of the solution. And this whole solution is 250 grams. So let's take a look at the solution for that one, or the answer. Okay, so the mass of the potassium chloride, okay, equals 5% of the 250 grams, which is 5% of the mass of the whole solution. So I just flip that into a decimal, and you get 12.5 grams. Okay. We also wanted to know the mass of the water. So all we do is we take that, there's only the two compounds making up the solution. So if this is the mass of the solute, the rest has to be the mass of the water. Just subtract the two and you get 237.5 grams. The other way you could do it, of course, the mass is 95% water. 95% of 250 grams is 237.5 grams.